Hello and welcome to another video on Git. In this video I'm hopefully going to give you a conceptual overview of Git as well as an introduction to the basic commands you need to know for the Git Command Line tool. So let's start off with our command line, and in fact the rest of our videos in this series will be on the command line using the Git command. Git Init will initialize a version control within a particular directory. So here we're within /video/git, and now version control has been applied to this directory. If we cd out of this directory, Git is no longer available here. Now, my terminal will tell me that this little green bar over here with the name master will tell me that Git is being applied to a particular directory. But if we didn't have the luxury of having such a tool or such a thing, then all we'd need to do is just write Git Status. If we cd out and write Git Status, we can see that we get a fatal, not a Git repository. So that's one way of being able to tell if a directory has Git being applied on it. So let's go back into our current directory and let's create 3 files. So we want file A, file B, and file C. And we want to start using version control on these files. We want to start using Git commands in order to keep track of the progression of our file. So maybe we want to create one snapshot for the beginning of our project, another snapshot for version 1 maybe, for version 2, maybe a new feature, etc, etc. So how do we do that? Well, Git likes to do it in 2 main stages. Let's illustrate this in our example. So we have our project, and we've applied init to our project. And our project contains various files. So in this case, we have file A, file B, and file C. And that's what we've got so far. Git creates snapshots in 2 main stages. We have our first stage called staging, and finally our snapshot. From our project to our staging environment, we add files into it. And in this environment, all we're doing is saying these files are being added to version control, and these files are potentially being added to our snapshot. So for example, let's say I put in file A and file B. Git now knows about these files to keep track of, as well as they're prepared to be saved, in other words. So once we've done adding, then our last step is to commit. Our last step is to commit. And our snapshot is created. So in this case, the snapshot contains file A and file B and various other information. So let's look at this translates to in terms of command line. So let's change file A. Let's add a few lines to it. And I said initially we add it to staging. So let's do git add file A. Okay, so if I get rid of my command output, I don't know what's going on here. I can do ls, I can have a look at my files. It's really hard for me to tell which files have been added to staging, which files have been committed, etc. The first real command I want you to learn is git status, and you should run this every now and then. Git status gives us a brief overview of what's going on in this directory in terms of the version control. In this case here, we know that we have a new file called file A that's being ready to commit, changes to be committed. In other words, it's currently in staging, this stage. If I was to add another file, git add file B, then I do another git status, then I have 2 files now ready to be committed, or 2 files that are in staging. And file C is not being tracked by Git. To finally create my snapshot, I do the second step, which is to commit. To commit, like so, git commit with a message, so -m, and we give it a message. So our message could be what features have been implemented, or what version this is. So it's usually nice to give a very descriptive detail of your commit. So in this case, this is my first commit with starter files. And there we go, we've created our first commit snapshot. So visually, what's really happened is we have a snapshot, or kind of like a block, and each snapshot in Git has a unique ID. I'm just going to say ID1, as well as the files that have been changed. Now Git likes to refer to the latest commit with head. Now there are other use cases for head we'll find out in later videos, but for now you can think of it as the current commit. Okay, cool. Let's illustrate further what we mean by this file is untracked. If I go ahead and change file A, because I've already added file A to staging once, then Git knows about this file, and whenever I do a git status, it would tell me that this file has been modified. Now, notice that the changes is not staged for commit, so I haven't added it directly, but Git knows it's been modified because I've previously added it to staging. Because I didn't add file C yet, Git doesn't care what I do to file C. So for example, if I do file C and I add stuff to it, and I do a git status, we don't see file C being shown to be modified. It just stays there as being untracked. So to illustrate it one more time, let's change file B and do a git status. We can see that file B has been modified. I can do a git add file A and file B in one line as well, and this will add them to staging. If I do a git status, we can see that a new message has been displayed, so changes to be committed. Previously it was changes not staged for commit, so now we've added them to staging, and finally we can do another commit. This is my second commit. Okay, what does this look like from a conceptual point of view, visually? Well, like before, I've created a new snapshot. And this snapshot again will have a unique ID, file A and file B. And what Git will do is we'll move head to this new snapshot. You can also think of head as the current working version in our directory, what version we're seeing, what version of our files we're currently seeing. And as I mentioned in our previous video, Git version control in general allows us to go back to previous snapshots. Our current snapshot, or every single snapshot following, will need a reference to the previous commit. What if we wanted to see this information in the command line? We can do a git log. So git log will give us a detail of all the commits that have ever been made, along with their unique ID, or in this case a hash, the author who made it, the date, as well as the message coming with it. And it will also tell us where head is currently located. So this is cool to know who made the specific commit and on what date, as well as what features may have been included in this commit. So you can see why having descriptive commit messages is important, especially when you're looking through your whole stack of Git logs to find a particular feature that may be breaking your project. And that is really it for the basics of Git. We've gone through Git Init, add, log, status, and commit. And really understanding this workflow is very crucial to understanding Git from a high level view, so you can go into more advanced concepts. And that's what we'll go through in the next future videos. Thank you for watching.